Hey there, welcome to session 6 of Thinking in Fusion, a video manual for Clickteam Fusion 2.5. Now, with the other sections, you've been able to dip into them and hopefully learn something new as a beginner. This one definitely builds on the skills that you will have learned in the other sections. If this is the first video you're watching in the series and you're a beginner, please go back and have a look at the other videos. And like we said, it's not a tutorial. This is a manual explaining the way that the features of Fusion 2.5 work. And we'll be covering more technical programming features as we look at groups, loops, and timed events. As always, we'll start off with some summaries. So to begin with, groups. It's nice to belong, isn't it? And in this section, we'll look at two different things that can be termed as groups. Firstly, we'll look at objects being grouped in qualifier groups. Then we'll look at groups of events in the event editor. Qualifier groups. In life, we're used to belonging to a larger section. A good example of looking at this qualifier groups is looking at how we group children in a school. Children have their own individual names, their own individual identity, but then they belong to a class. Now there may be many classes in a year group. Then year groups may be grouped in lower school and upper school, and the school itself is one collective group. If in an assembly the teachers had to refer to each student individually, then when dismissing people it would take ages. They can just say, Year 8, can you leave? In effect, giving a command to around 180 students all in one go. Or, as more often was needed, settle down Year 9. Nearly every object that you add into your frame can belong to one or more qualifier groups. Just select your object, or drag around a box and select multiple objects. Go to the Events section in the Properties toolbar, click in the blank space for Qualifier, click Edit, click Add, and choose a qualifier group. Quick note, all of these qualifiers don't have any code attached to them until we, as the programmer, add it. So just choose the best description or icon picture that will help you remember how the qualifier group will behave. Then, in the event editor, we can now create conditions and actions based off that qualifier group, allowing us to have one condition and one action which will apply to all the active objects that are in that qualifier group. As you can imagine, that not only speeds up but simplifies the creation of events. Now while we're in the event editor, let's look at event groups. As I've told you before, in Fusion 2.5, in the event editor, the black events get run through in order from top to bottom. Now, in order to have a collection of code that doesn't always run, that you can choose whether it's activated or deactivated, you can put it in a group. You can right-click on an event number to insert group, or from the top menu, you can choose Insert Group of Events. The title you choose doesn't affect the way the group works, but is useful for you to understand what the group is for, so enter something that's clearly descriptive of what it does. You can add a password to the group so that it can't accidentally be altered and edited, but we'll look at that when we look at creating template games in Fusion. You'll notice the group shows all of its conditions indented, so that it's not in a straight line with the rest of the events. So we'll add a new condition, the timer, every 100th of a second, and under the qualifier group that we've added, group balls, we'll increase their size. So the scale will equal the current scale plus 0.01, a 1% increase of their original scale. This group is starting off activated, meaning the code will run as soon as the frame loads. We'll add an event in to deactivate it. So we'll add a new condition from outside of that group upon a key press, spacebar. Then for the action, under the first column, under the cogs, under special, group of events, we can choose to activate or deactivate. Well, we want to deactivate, so we'll select that, then select the group we want to deactivate and press OK. Now when we run our application, the balls will grow until we press spacebar, and then that will deactivate any code that's within that group of events. There's not too much to add in that, but in the in-depth section, we'll look at the benefits of using groups and also some of the things to watch out for. That's both types of groups summarized. Let's look at loops. Loops are used in all types of programming to make the code much simpler, to allow a really repetitive task to be done in just a couple of lines of code. We'll look at fast loops, code that will repeat a number of times, similar to a for loop, and a count loop, checking objects individually, similar to a for each loop. Firstly, fast loops. Here's a quick summary about fast loops, but I recommend the in-depth section at this time code. A loop can be started in the event editor. So I'm going to say new condition, the mouse pointer and keyboard upon pressing a key, and I'll choose spacebar. Under the special, if I right click, I can choose fast loops, and I can start a loop going. I need to name the loop, and it's important that I know what the loop is named. So it's useful to use really basic spelling. I'm going to call my loop add 10. Then Fusion wants a value for how many times the loop will occur. 10. Now on its own, this will do nothing. We now need to create the actions that will happen in the loop. Under new condition, special, on loop, and then the same exact name. So for me, it'll be add 10. That's our condition. Then for our counter, I'm just going to add 1 to counter. If I run my application now and press spacebar, 10 will be added to the counter. I've only added in 1 condition and 1 action, but that is being looped round, as in repeated, 10 times. And the important thing to know, even in the summary, is that Fusion 2.5 will wait till it completes a loop. It has to complete all of the cycles of the loop, the repeating of the loop, before it runs any rest of the code. Count. The count is not only a Sesame Street character, but in Fusion 2.5 is a special type of loop. Either an object or a qualifier group of objects, checking each one individually. This is vital to be able to have conditions that reference the exact object that the action should apply to. For an example, I'm going to have characters move around the screen. I'm also going to have pressure pads that they can stand on. If they stand on a pressure pad, I'm going to change the animation frame to 1. If they're not on a pressure pad, I'm going to change the animation frame to 0, back to how it is originally. The overlapping rule seems to work great. As soon as one overlaps, that particular active object changes its animation frame. But if you look closely, when some active objects step off from the pressure pad, they don't change back to their original animation frame. That's to do with the syntax, the grammar of the event that's happening. So on the negated line, the line which says about the character not overlapping the pressure pad, Clickteam will check all of the characters, and as long as none of them are overlapping the pressure pad, then it will enact changing the animation frame back to 0, putting them back to their original state. But obviously, someone might step on a pressure pad and step off a pressure pad, while another one is stepping on a pressure pad, thus meaning they don't get to change back. Everyone needs to be off the pressure pads for everyone to get changed back. And this is where a count would come in useful. So under new condition, under special, I'm going to add it always. Under my character, under the characters, I'm going to right click and choose count for each object. And then I'm going to give it a name. So make sure that your spelling is right and you choose a simple word or phrase. We need to name the count, so use a simple phrase that you can easily spell and put it inside the speech marks. So a new condition for the character, and this time it's not under count, it's under loops. So just be aware of that it won't be called count, it's loops. and we'll enter the name of the counting loop that we started. I will then insert into that condition by right-clicking on the words and choosing Insert that the character is overlapping a pad, but then we need to negate it for not overlapping. And then I'm going to have the exact same action of setting the animation frame back to 0, the original picture. I'm just going to remove that event of not overlapping the trapdoor that we no longer need and try it out. And now it works perfectly. So now Fusion doesn't compare all of those characters as a whole, it checks each one individually to see if they're not overlapping to action the change of animation frame. And like with other loops in Clickteam, the count will have to complete before any more code is ran. So on to the last summary, timed events. Like the secret of good comedy, timing is also really important to good gameplay. When a character dies, to go straight away to the game over screen is very abrupt. It's only fair to give them a bit of breathing time, to have a few seconds for the person playing the game to come to terms with the loss of their character. So we're going to alter the events of this game. When the number of player 1's lives reaches 0, rather than jumping to the game over frame, we're going to trigger a timed event. So if you right click under the timer, we can fire an event after a given delay. We'll set it to 3 seconds and press OK. Then it asks for a name of event. I'm going to title this Lose. Then I'm going to remove the action of it jumping to the next frame. So when player lives reach 0, it will trigger this event, but only after 3 seconds. We could use that time to play a sound to the player to audibly tell them that they've run out of lives. We can insert a sample, play the sample from a file. We don't want this sound to constantly play, so we'll insert a special limit condition. Then we need to make the timed event itself. What happens? So under New Condition, click on the timer, choose On Event, and for me this is going to be Lose, making sure it's still in the speech marks. Press OK. And at this point, we will jump to the frame for game over. Now when my player loses their lives, the sound plays, and then it's game over. Timed events can also be used with 0 delay, in effect creating a function. And we'll look at that in the in-depth section at this time code. Qualifier groups, in depth. So let's start off with a real Fusion example. Some bouncing balls. Each one is a different active object. The red one, yellow one, green one and blue one. Each of them have the movement bouncing ball. If I was to set up events for the balls leaving the area or the balls hitting another ball bouncing, I would have all these lines of code. But that's not needed. If I put all the balls into a qualifier, in the property toolbar, events, qualifier, blank space, edit, add, there just so happens to be a qualifier called balls, but I could use any of these qualifiers. They're all just empty groups at the moment. So put in the balls qualifier. Now in the event editor, I can have one rule to say that if any of the group balls tries to leave the play area, then group balls bounce, and that will reference the specific ball that tried to leave the play area. The action will happen just to that ball. And then again, I can just say a new condition. If the qualifier group balls collides with another qualifier group balls, as an action, I can choose movement and bounce. That will be any combination of any of those in that group. The red and the red, the red and the yellow, the red and the green, the red and the blue and the green, any of them collide with any of them, they'll bounce. And I can do away with all of these lines. Qualifier groups allow you to add multiple types of the same object into your game without having to add new code. So here's some things to be aware of. qualifier groups apply to that type of object. So putting some string objects in and adding them to the qualifier group of balls, you'll now see that I've got two different qualifier groups in the event editor. One for sprites, the active objects, and group balls text for the strings object. Now Fusion has to do this because some actions cannot be applied to certain types of objects. You can see if I right click underneath the group balls sprites, I get all of the actions for an active object. But then if I right click under the group balls text, that will give me all of the actions that apply to strings. So even though two objects can share the same qualifier group, if they're not the same object type, you will have a separate column for them. And the way that conditions and actions work will be like they are separate groups, just with the same logo. So here's another real in-game example. Here I've got a platform game that uses the physics movement. I want to have it multiple player, so I put the player character in a player group. I also want all the objects that are able to be pushed that are physical. I want to put them in a qualifier group. And so I have a few choices. I like to put them into group obstacles. But I could obviously choose physical objects. I could just choose fog. I could choose anything that I wanted as long as I, as the coder, know what that group's for. And it's sometimes useful maybe to add a string file to the side of your game just to make notes of what qualifier groups get used for what. Say if I want some of the objects that are in the obstacle qualifier group to be able to be destroyed if they're shot. So I'm going to add them into a secondary qualifier group. Just by clicking on the space next to qualifiers, edit, and add. And there's a useful one called breakable. Say if I want some of my objects over time to shrink, I would add them to a qualifier group. This time I'm going to use dissolving because that's quite similar to shrinking. Now, in only a few lines of code, I can tell the game that if the player collides with an obstacle, the player stops and the obstacles stop. If an obstacle collides with an obstacle, they both stop. But also I can tell it that if a bullet collides with a breakable object, it gets destroyed. And I can also say that every second, the qualifier group dissolving, the scale is set to its current scale minus 0.1. And when we run the game, you can see the gameplay set up just by me choosing qualifier groups for the object. Now you can go much more advanced than this. We can start using alterable values. Because we've got separate objects in the same group, we can set different initial alterable values for each object. So for this rock, I'm going to set up an alterable value called health, and I'm going to set that to 10. But for this ice, I'm going to give it a health of 3, but I'm also going to give it a secondary alterable value of shrinking of 10 to represent 10%. Now in the code, I can reference those alterable values, so each object has its own attributes of health and of the speed of shrinking. So rather than if breakable is hit, destroy it, I'm just going to say that if breakable is hit, we'll subtract 1 from health. Then, if any of the group breakables' health are lower or equal to 0, destroy them. And for dissolving, I'm going to alter it. Rather than subtracting 0.1, I'm going to subtract from the dissolving the alterable value of shrinking, but because it's a percentage, I'm going to times it by 0.01 to make it out of 100. Now, I'm going to be careful that I make sure that each object that's within these groups, that the alterable values are in the same positioning. The event editor works off that index. So if I edit the first alterable value, that's alterable value A by default, number 0, all of those first values in all the objects in the group will be edited. This is important because if you're using health for the first alterable value for one object, it needs to be the same across the whole group. And making sure they have the same titles is useful as well. You can see in the event editor, with alterable values, that if you haven't set the names of your alt rule values to be the same across all of the objects that are within that qualifier group, then it will just default back to alt rule value A, alt rule value B. It can be useful to make a note of which alt rule values get used for what. Now pay attention to the numbers next to your alt rule values, because you can reorder your alt rule values in Clickteam by dragging them around, and you can now, in the latest version, copy and paste alt rule values between objects just by selecting them and Ctrl-C and Ctrl-V, or right-clicking. This issue of alt rule values not showing their names in the event editor happens in the global event editor, depending on the Clickteam Fusion 2.5 version you have. In the free version, you won't be able to access the global event editor. That's events that are true across all frames. In the full version, you can access it, but you won't be able to use conditions or actions on qualifiers directly. Then in the 2.5 Plus add-on, the DLC, you can. You get full access to using all the qualifier groups within the global event editor, meaning you can make much larger games with much simpler code. Throughout the game making process, qualifier groups become vital, so we will reference qualifier groups again and again in later versions of Thinking in Fusion, and even in this video, and especially as we look at the count loops. So feel free to watch back anything that you might have missed. The qualifier groups are done, so let's look now at the event groups in depth. Now, because the way that Clickteam runs through the code from top to bottom, following all the black events, and then using all the green events as a trigger event that just jumps the queue, when events are in a group, it allows you to make all those events in one go active or inactive, turning them on or off. So we have an example here where we'll have a shield that will follow the player, and we've contained all that code in a group. The shield is placed outside the play area before the group is run, and then when the group runs, it's placed on the player. But we don't want the shield to start off being active, so we're going to right click on the title of the group and turn off active when frame starts. Now, the shield isn't with the player. Now I want to make this quite clear that you can activate and inactivate lines of code, and that is different from activating and inactivating a group. If you right click on a group and choose to deactivate it, if under an action you activate it, it won't become active. We'll add a condition in that when the player mask hits the shield icon, that activates the group. And we touch it, and the shield is now linked to us. We can add a timed event on there to deactivate it. For testing, I'm just going to set it to 3 seconds. And I'm going to call the timed event no shield. So I'll start a new condition, and on the timed event no shield, under special, under group of events, we'll choose to deactivate the shield active group. So the shield's placed off screen. We touch the shield icon and the group becomes active, placing the shield on us, and then the timed event no shield deactivates the group. Groups are useful because you can copy and paste huge lines of code. You can also move sections of code all in one go, and you can also contract and expand them by double-clicking on the title. You can also nest groups inside, that is, have another group within a group. You can see the indentations go further out. But be aware, if the parent group is inactive, then all of the other groups inside it will be inactive as well. Groups are amazingly useful if you have games that have different turns of play. Now, if you have the full version and also the 2.5 Plus DLC, you get something called the Event Explorer. The Event Explorer allows you to jump to any group in the event editor, making it even easier to work with large programs. And we'll talk about teamwork and making larger games in a couple of sessions' time. That's groups in depth. Let's look at loops in depth. Loops. In programming languages, there's many different types of loops. Fusion naturally loops through the code. This is like a while loop. While true. While true is true, all the lines of code will be run through in order. The fast loop is like a for loop. The for loop takes a variable, that's a counter, and each time it cycles through the loop, it will add to that counter until the for condition is met, as in, until the counter equals the amount of loops you want to do. An account loop operates a bit like a for each loop, which goes through an array, or in Fusion's case, objects, one by one, checking them individually, referencing them one by one. So let's look in depth at how these work. First off, fast loops. Because the loop commands stop any other code happening, having a loop at start of frame to position things is really useful. So if we've got some stars that we want to position randomly, and just did a new condition that the number of stars are less than 300, then create a star and put it in a random position, they'd be placed on screen as quickly as the frame rate of the application, so 60 frames a second by default. So if we wanted randomly placed at the start of the game, then the fast loop is the best thing to use. At the start of the frame, it calls the loop. Star 1, star 2, star 3, all the way up to star 300 are created before any other code is ran. I'll replace this condition with the on loop for stars. And if the loop's small enough and the actions are quick enough, the player shouldn't notice. The stars will be put there before anything else happens. Now if we want, we can add an action to stop a fast loop from completing all of its cycles. So I'll give you an example. I've got a list here, and in the list I have the word end written in capitals so it stands out. I also have a counter so that I can add to the counter each time I go through the loop. I'll start a loop called make fruit. I'll run it the number of times that there are items on the list. On loop make fruit, I'll add one to the counter. I'll create an object by name. The object I'm going to create is the line of the list that the value of the counter has got to. So I'll start off at 1. Then, in terms of positions, I'm just going to randomly position it on screen so that I can create multiple fruit. And in terms of the layer, we're covering that in the next video. So as you can see, when I run it, it creates each item on the list, going all the way from the top to the bottom. But there's no object called end, so that's ignored. But there's no object called end, so that's ignored. Now, if I add multiple on loop conditions, I can check whether the line says end. So I'll insert and compare two general values. I'll compare the list at the line with the value of the counter and see if it's equal to end. If it is, then under special fast loops, I will stop the loop and I'll use exactly the same name, make fruit. But of course, I still need to create the fruit. So I'm going to drag that action down to this on loop and remove it from the line above. So we're ending up with 3 conditions: on loop, adding to the counter, on loop, checking for end, and on loop, making the fruit. You can now see that when I run it, we have each of the fruits created until it reaches the word end. So some things to be aware of about fast loops. Having an action to run a fast loop that doesn't exist will just mean nothing happens. Running a fast loop 0 times will also mean nothing happens. But if you action starting a fast loop and it runs less than 0, so -1 or lower, due to the way that Fusion counts, that number will never be reached and the game will crash. So if the number of times the fast loop runs is dynamic, if it's a variable, it changes, make sure it doesn't go below 0. In the number of loops, you can use the maximum of 2 numbers calculation to make sure that the maximum is 0. Occasionally, if you have multiple actions triggered by one condition, the loop action might not trigger in the order that you expect. Therefore, it's really useful that if you create a second condition with the loop action on, you know that that loop will be triggered either before, if you place it higher than the rest of the actions, or if you place it below the other condition, it will happen afterwards. So thinking back to when we looked at enemies and fake AI, in the later stages we only had one enemy on the screen when we're looking at fake AI sight. That's because we haven't learned about count loops until now. Count loops are vital for games where individual objects have to have their own behaviour based on alterable values or their position within your level. Let's look at adding a health bar to multiple enemies on screen. Now previously, the enemies would have to be the same active object, but now we know about qualifier groups, we can put all of our enemies into a qualifier group, and I'll use the qualifier group enemies. But bad might work just as well for you. We'll also add a counter in, which will be the health. I've already set up an alterable value for each of the enemies called health. I've also set up one called counter ID, and we're going to use this alterable value to link the enemy with the counter. Traditionally, health is shown as a horizontal bar, so I'll change it to be that. And in the runtime properties, I'm going to turn off create at start because I want Fusion to create the counters one by one for each enemy. We're going to do that in the event editor. So at the start of the frame, we're going to start a count for each qualifier group of enemies, and I'll call this setup. I'll create a new condition under the qualifier group enemies on loop setup. We're going to create a counter object, and we're going to do that relative to the group enemies. Counters hotspots, or their point of location, is in the top left. So I'm just going to drag it diagonally top and left, meaning it will go on the specific group enemy that it's looking at during the count loop. Now, while it's counting through each enemy, it knows each one I'm specifically talking about. Now we need a way for Fusion to know which counter belongs to which enemy, and for that we'll use fixed values. The objects made in the game are given a number, like an identification number, but it's a number unique to them. It's called the fixed value. So that we can link each counter with the group enemy monster that it belongs to, we're going to use the counter's fixed value and place that in the monster's alterable value of counter ID. This means that later on we can reference which counter moves with which monster. So under the group enemies, under the alterable values, the counter ID, we're going to set that to the health counter's fixed value. Before I do the next bit of coding, I'm just going to set the properties of the counter, meaning that the horizontal bar will properly represent the amount of health left. So the minimum value for health is 0. I'll set it to that. And the initial value I'm going to set to be the same as the maximum value. In the code, I'm going to reset the maximum value to be the exact value for the group enemy's health variable. That is, whatever the monster's health has at the start of frame, that will be the maximum value for that counter. We've got our enemies and we've got our health displayed on screen. But as they move, the health stays where it is. Close our test application and go back to the event editor, and we're going to add in another counting loop. So we're going to put it under a new condition, special, always. Underneath the qualifier group enemies, let's right click there and do a count for each object. Now previously we called one setup. We need a different name. So I'm going to call this position. Then a new condition. Under the group enemies qualifier, we're going to go to on loop and position, making sure that we spelt it exactly the same as we did previously. Now we need to tell Fusion which specific counter it needs to position. It's looking at one particular enemy, but if we reference positioning the counter, it will position all of the counters to that one enemy each time it loops. So the last enemy it looks at, all the counters will be on top of them, moving from one to the other in between. So it will just look like all of the health counters are just on the last enemy in that loop. We will right click on that count condition and insert. And what we'll do is we'll go to the health counter and we'll compare its fixed value. Make sure you choose fixed value, not instance value. And that needs to be equal to the qualifier group enemies, its counter ID. So it's looking at one specific enemy and seeing if any counters on screen has the same fixed value as the ID within the enemy, matching it up to the one that we created earlier. That specific one counter will be positioned relative to that one specific group enemy object. But now we need to update the health. The health may have changed on that enemy. So if we right click and go to set counter, then from the qualifier group enemy, we can right click there and in its ultra values, we can get its health. And press OK. So now this means that the position is set to follow the enemy and the health updates. What I'm going to do is add a command now to mean that every time that the weapon hits the group enemy, that the ultra value health, we subtract 1 from it. Then we can check that if any of the group enemies has a health equal or lower to 0, we can destroy it. So you can see when the weapon hits the monster, the ultra value of health goes down, and then the counter is adjusted as soon as that happens. But to make sure that the counter is destroyed when the enemy is destroyed, we can insert that if a fixed value of the counter equals the enemy, it also gets destroyed. Now you could do something more advanced. You could have it always that the counters fade out. You could add another event into that for each, checking that if the counter matches up with the group enemy's counter ID, but the value of the counter doesn't match up with the group enemy's health variable, as in the health has changed, then the counter becomes visible again. And you can add multiple conditions for any for each, and Clickteam will run through them in order, only running the actions if the condition is true. So going back to the beginning reference of the fake AI of the enemy site, we could only have one enemy looking for a player. But if each of the site object carries the fixed value of the enemy it came from, that way, when there is a collision, you know which enemy has spotted the player and which one should react. Linking things together this way allows you to have some very complex mechanics in just a few lines of code. Now let's go back to something far simpler, multiple timed events. Timed events trigger an event, and you can have a delay. You can also choose to have a number of timed events triggered after a certain delay. You can choose the delay of the first event, and then the delay of the subsequent events. So in this example, we've got a monster that fires fireballs out. We've set it that every 100th of a second, it thinks of a number between 1 and 300, and if it chooses the number 1, we'll fire events a number of times after a given delay. Under the timer, right-click and choose Fire Events N times after given delay. So the delay before the first event, we want to be instantaneous, that they fire the first fireball immediately. So I'll choose it as 0 seconds. Then the number of events. So we want it to fire 3 fireballs, so I'll write 3. And the delay between each event, we're going to set that to half a second, or 50 hundredths of a second. We could also use a calculation, allowing us to get the expression editor up, and where we could choose something to be random, or based off another value from within the game. I'm not going to, so I'll cancel that, and leave it at 50 hundredths of a second, a half second. Finally, it asks for the name of the event. So I'll call it Fireball. I now need to create a new condition called Fireball to match up to it. So new condition, the timer, on event, Fireball. Under the enemy, I'm going to set it to launch an object, the Fireball, in selected directions, and I'm going to select all the directions, so it'll be a random direction. When we test the game, you can see that the enemy fires fireballs out 3 at a time. A very useful feature of timed events is timed events can act in the same way as a function does. In traditional programming, you may have a function, a set of code that's run to complete a certain outcome. Now this function could be one line of code or several events altogether that gets called throughout your program. So let's look at using timed events as a function in that previous example of the game over. When you lose your lives, it plays a sound, and after 3 seconds it calls the timed event lose. But I may want to call that timed event instantly when the player presses escape. So I can say new condition, the mouse pointer and keyboard, the keyboard, upon pressing a key, escape. I can choose to run the timed event with 0 delay. So right click under the timer, fire an event after a given delay, 0 seconds, and then name the event, lose. And that will call the exact same line of code as if we run out of lives. But this time there's no delay, it's just doing it immediately. And I could choose other scenarios in the game of instant death when the player falls off the screen. I can fire an event after a given delay. Maybe choose 2 seconds, play a sound of falling, and then trigger the event. That means at any point I want to change the way the game's over, I have all these conditions that take me to just one place. So I just need to change that one line of code for lose. And in the multiple scenarios where the player loses, it will update all of those ways. And the other thing about timed events is that they will run until completion and then the code will continue. So if you have a function that needs to span multiple lines, you can set your condition to onTimerEvent and then insert another condition as well. So when that timed event is fired, when that function is called, it will go through every single line that has the condition on event and the name of your event. Fusion will go through them one by one in order and only run the actions if the condition is true. And at the end of running that code, Fusion will return back to the condition that called the timed event and continue checking the code from there. As these timed events can get run out of sequence of the normal code, and they can get pretty complex if you have multiple lines, it's a good idea to place them in a group. That way, the group name can be used as a description for the function, but also it can be contracted when not needed or expanded when editing the code. Well, that covers groups, loop, timed events, hopefully giving you a lot more power in your programming to make your games much more advanced without adding lots more code. Next session, we're taking a break from all this technical stuff and looking at special effects, along with saving and loading files from your computer. Take care. See you then.